All right, hello everyone. Welcome to Teal Tech Tips and Tricks, or I'd like to call it T4. The purpose of this project is to continue educating the digital forensic community on the latest tools and tricks to help you with your investigations. My name is Kent, and I'm the coordinator for this project. Just to lay out some ground rules, you can chat on the right. You can post to everyone or only to myself, Amanda, or Ryan, the presenters of this presentation. If it's related to the content, I advise you post to everyone. And if you're having trouble hearing, please click reconnect up top. You should see a button. And with that, I would like to get right to it and introduce Ryan, who is the president of MOS Equipment.
Hey everybody, thank you for tuning in. Appreciate you guys joining us. So yeah, like Kent said, my name is Ryan. I'm the president of MOS Equipment. And my colleague, Amanda, is going to be joining us today. She's going to be manning the PowerPoint and answering some chat questions. If you have any questions during the presentation, feel free to ask them. We'll do our best to answer them. If not, you can hold them to the end. So we're going to be talking about Faraday shielding in a nutshell. We're going to go over sort of the latest situations that require shielding, talk about some tips and tricks as they relate to process and our products, and then offer a little bit of background information on Faraday bags and some of the stuff that you may see out there to help you understand what they do and what they mean. We won't get too much in the weeds there. I think most everybody's probably familiar with Faraday shielding on the surface, so we'll kind of explain how it relates to the latest situations. So let's go back to the PowerPoint. All right, if you are like Jackie Chan here, you may be confused on what is a Faraday bag, Faraday cage, EMF, EMP. There's a lot of kind of nomenclature out there. They all relate to the same thing, and that's RF shielding, essentially, is another way that in our industry in forensics it's referred to. Next slide. So what is a Faraday cage? On a basic level, again, I'm sure everybody's pretty familiar with it, but generally speaking, a good way to think about it is like a waterproof bag. So if you have a waterproof bag, you want it to be fully enclosed. Even if there's pinholes, water can get through. Same thing with the Faraday bag. It has to be fully enclosed. We build them to a certain specification using materials that are copper and nickel, primarily for our bags. That's what most of them are made out of, and that waterproof bag analogy kind of helps to understand how essentially temperamental they can be, which relates to wear and tear too. So, sorry, I had someone writing in chat here. Okay, so Faraday bags, let's go to the next slide. Alrighty, so we're going to talk a little bit about the frequency spectrum. So there's a big radio frequency spectrum. What we're concerned with primarily as forensics investigators is going to be the consumer device spectrum for cell phones, Bluetooth devices, tablets, laptops. So that's going to be in the low megahertz range, around 100 megahertz, right around there, up to about 5 gigahertz, okay? So as you know, your Wi-Fi operates 2.4, 5, cell phones are around 1 gigahertz or 2. Beyond that, we have ranges that we're not really trying to block, and other products would be required to do that. So an interesting kind of example would be if you have a door entry key fob, that may operate at around, let's say, 100 kilohertz, which is much lower. That may not work inside of our bag. It may go right through. So if you're using something like that to test, it's not a good test. We'll talk about that later. By the way, a lot of these, there's links on the slides for later. You'll be getting this presentation. Feel free to dive into there if you're interested in learning more about the topics that we're talking about. All right, won't talk too much about this, but what's kind of interesting is on the lower spectrum of frequencies, you could have a wavelength and an amplitude that's as long as the universe. On the higher end, you could have it the size of an atom. And in between, we're concerned with that middle range for mobile phones and devices like that. Next slide. Okay, a question we get all the time is 5G. 5G is just, it's coming out now. A lot of people, there's not a whole lot of understanding of how it's being implemented. It is changing frequently. We get the question of, will your products block, if I purchase them later in the future, will they block 5G? It's a good question, whether using our products or another company's. There's also health concerns. And we're not gonna really be touching on that, but it's on people's minds. So one kind of point that's worth mentioning with 5 gigahertz is it was originally intended, from what we research and we're seeing, to be around 80 gigahertz. up to 300 gigahertz, pretty high frequencies. The problem with those frequencies is you have kind of a wall of information that's moving, and it's easier to get obstructed by buildings and structures. So it's good for line of sight in areas like Nebraska, let's say, not so good for buildings in New York or Los Angeles, or places that are going to have a lot of obstructions. So to relate it to our products, right now we're not seeing any issues with 5G. In areas like New Jersey, where it's already been implemented, if you have shielding products, at least ours, from the feedback we get, we're not seeing any faults. Maybe it'll change in the future, but as of now, should not be a concern. Next slide. Okay, so 5 gigahertz and above, you have this area where you need a lot more line of sight. Below that, in the frequencies that we're used to in our houses, 2.4, 5 gigahertz, cell phone frequencies, they're semi-penetrable, so they can move around walls, fill spaces, and then below that, those frequencies can go through even, concrete walls, and they're much more penetrable. So just kind of interesting to note. Okay, so this is basically how easy is it to block RF signals? In layman's terms, it's kind of interesting to know as an examiner. It helps us for two reasons. So the signal or the frequencies that are easy to block are going to be cell, GPS, Bluetooth. Those are much easier. It's much harder to block Wi-Fi. 2.4, 5 gigahertz is even harder. And then if you have, let's say, a high-powered router like a Cisco router or something, that's going to be even harder to block. Okay, so why do we want to know that? There's two reasons. One, if you're in a lab and you have, let's say, a router inside of your lab that you could control, you don't want that. If you have a suspect device, let's say, that's been connected to an AT&T hotspot in the past, that comes into your lab, connects to that AT&T hotspot, which would actually mostly likely be outside of your lab. And if you can mitigate against that, you definitely should. You may lose your evidence. So try to get rid of any sources of signal that's possible for you to do, so you have the best analysis environment in your lab. All right, and then actually the second, let's go back really quick. Second implication of that is for testing. So for Faraday bags, whether you're buying ours or another company's, a good test, kind of a tip to make sure that it's still working properly, is to get it as close as you can to a router, whether that's like a home router, just a normal power one, or high powered if you can. Put the phone inside of it, get it near it, close it, and then use our apps, which there's links to on here, or just check the signal to make sure that it's blocking. That's and put it on 5G. That's kind of your best at home or in the lab test without a signal analyzer. Make sure that it's working. Next slide. Alrighty, right, trash can, bad. Tin foil, not so good. Purchase a bag that's been designed for this. We definitely recommend that. Sometimes tin foil has been used in the past. It's just not a great solution anymore. And you're gonna go through a lot of tin foil. All right, why is shielding important? So the kind of original justification has changed a little bit. The times have, the equipment that's being used now is requiring a little bit of a different process and a reason for why we want shielding. Originally, it was to make sure that devices aren't bricked, that they don't get overwritten with remote wipe command, which, by the way, if a phone is exposed even for half a second on a network, that remote wipe command could come down. That's all the phone needs, and then it begins wiping its own evidence. So it doesn't have to be connected for long. To maintain chain of custody, so if you have GPS track points coming in after the point of seizure, you're getting cross-examined on why that is. You have to answer that question of how you made a mistake and so on. Nowadays, we're seeing tools like GrayKey where it's more advantageous to have the phone in an after first unlock state, where it should be live, to keep it live all the way to the point from seizure in the field out to the lab, or into the lab rather, requires a process that's different than what's been out there before. You can't just put it in airplane mode necessarily, or take the battery out, or SIM card. So that requires sort of a combination of process and product, which we'll talk a little bit about. And airplane mode, just to go back for 1 second, airplane mode used to be a little bit more secure. Nowadays, an iPhone, I think most of you probably are aware, you could put an iPhone in different antennas. You can turn it on, even with airplane mode on. Android, there's a setting when you set up the device that'll let you even have the phone communicate on the network despite airplane mode. So it's not that secure. All right, so the goal is get everybody on the same evidence processing plan as much as you possibly can. Use some equipment that supports that process, and let's see. Yeah, right, from seizure all the way to the front office, into the lab. And the tools these days are going to allow us to get a better chance of breaking the passcode with GrayKey if the device is live, subsequently the most data, and a faster investigation. Okay, so we get questions a lot on what exactly should we do? What equipment should we be using for this process? The best sort of, the agencies that are implementing the best process that we've seen is going to have a field component, a front office component, and the lab. Now this should be intuitive. You may have this set up sort of, you may have it set up in full. The front office component is really important because it takes away the communication from the field guy or gal with the lab, right? So if you have an officer coming in the middle of the night and he's got a phone, he's not going to be calling the examiner trying to figure out what to do with it, who may, not pick up the phone or so on, and you're not going to have devices on desks, dead, unshielded, bricked evidence. So we're going to talk a little bit about what we're seeing as the best process from agencies now that are implementing shielding all the way across the spectrum. Yep, we're good. Okay, so this is an infographic that we built that helps provide a little bit of transparency into this process. You can get this later. The main idea with this, you see those three separate categories: field, front office, lab. Within that, you have some different budgets to help you understand what you might need to be spending in that. Again, if it's another company's products, it at least just provides like a framework for what you need to do to make sure that all the way from the point of seizure, the device will end up live and shielded when it gets to the lab. So we'll talk about those different components here. Okay, so the field component is where this all begins. Anyone handling evidence in the field should have some sort of shielding. We've broken it into two primary categories. The first one is going to be the wider range of individuals that are out possibly encountering evidence maybe once a week. That would be patrol officers. Maybe they'll pick up a phone once a month or something like that. If you can offer your patrol officers a bag, this is 23 bucks. It's a Velcro Faraday bag. It's just standard. It's the most widely sold bag probably that we have. This, if it can go in every patrol vehicle, it's a good idea so that when they encounter a phone, they can put it in here. At least if the phone ends up maybe dead by the time it gets to the lab, it won't be bricked. So you will have a chance to recover some of your evidence. Now we have the component of investigators, CSI, homicide, narcotics, those groups that will encounter devices inevitably on a much more frequent basis. They absolutely for sure should have some form of shielding. So one option that's we're seeing more widely distributed as far as the products that we have is this. This is a charge and shield bag. Okay, so what this lets you do is, let's say you want to distribute out 10 of these, at least have them maybe in your station for warrant searches, or distribute them out to detectives. Once you get a phone, you can place it inside of here. Actually, what you want to do is find the right cell phone tip. So that's going to be held inside of here. This comes with a number of cell phone tips. You'll put the device inside of here, connect it to the USB block that you see over there, roll the top, and then it's going to be shielded. And then this can be connected either to a wall outlet in a vehicle or to a battery and so on. That's going to allow this to be shielded and charging at the same time. And you can see the device through here to make sure that it's signal cutoff, that it is charging. The upside to this is this fits into the process pretty seamlessly when it needs to get to the front office or back to the lab, because the charging is external. So it can stay charged for a week if you need, or longer, and then can end up on the examiner's desk like this and charging and shielded. The downside is this is $300 to $400, so you're not going to be giving this out to every patrol officer. One other option that's pretty common right now is a battery bag. So this is much cheaper. That's an upside, $130. When you get a phone connected to the battery and it goes on the inside, that's good because it's going to stay charged. You can see the battery power through here. It's bad because this, once it opens, the battery, the phone is going to be exposed to power, so you don't have that external charging capability. So it's a little less seamless from the field through to the lab. All right. Oh, sorry. One thing to mention. So a number of our forensic products now include this magnetic closure. So if you have a box, whether it's a Ramsey box or you've got ours, you have these gloves. These are pretty susceptible to wear and tear and getting destroyed by the Velcro bags. So if you're noticing that in your lab and you're finding that you're replacing gloves and it's expensive and a pain in the butt, try the magnetic bags. It's a good option for lengthening the life of the products. All right, so next slide here. Okay, front office. So I mentioned the reason why we want the front office situation in place, so we have that buffer in between the field and the lab. The products that we've put together that support this process vary a little bit based on kind of what's coming in. So if you have detectives coming in and they have these charge and shield bags, for example, what they can do is, this explains kind of how to do this for maybe someone who's not trained. If they are, great. But they'll open a compartment here, which these are locking compartments, get this bag charged, stow it in the compartment, close this, drop the key into this box, and now the bag is locked, it's charging, and it's shielded. If you don't want to purchase a locker, you've got some other solution, you can use the bag separately or in other companies. The point is just to kind of have that buffer in between so that there's no question about whether the device is going to end up live and shielded on the examiner's desk. Now, if you have patrol officers, we get this question a lot. Okay, you know, the cop comes in, device is in here. Again, let's say it's the middle of the night. What do you do? Because it can die inside here and you want it to stay alive. If you can put a box out in the front lab with instructions on it that will allow someone to come in, put the bag in, close the lid, and transfer it from this Faraday bag into one that will allow it to stay charged, that's a good piece of the puzzle. It's a good process to allow these to end up charging and shielded. Okay, then we get to the lab. Everybody's most familiar component. So if you're working in the lab, you have devices that are pretty much in three general states. You have pre-examination, you have examination, and post. If they're waiting to be examined, you want everything shielded, everything charging. The charge and shield bags are a good way to do that. In this little infograph, you see a few on the desk there. That's a good way to accomplish that. If you have them maybe in a box, a separate box, charging, that's a good way to do it as well. I will say that one thing that we always advise is redundancy. So if you have a box and you've got 20 phones in here and they're all charging, it's not the best idea necessarily to have them all together and not redundant or separated at least. If someone were to open that or one of the seals failed, which can happen, you know, these seals fail, so do the gloves, like we mentioned, all of your devices are all of a sudden exposed to the network. So not a great scenario. So have them at least one per bag or a few per bag separated out. Let's go back to the infograph here. Okay, so during examination. So a lot of the situation with shielding now that we get questions about relates to GrayKey. So how do you operate GrayKey in a box? Sometimes we get the question of, okay, that little, the lightning port on the outside, can you get a filter for that so GrayKey goes on the outside? It's not feasible to do that for the tech and for the filters. What we're doing, or what we're seeing implemented, is to put GrayKey inside. And if you have the geofenced license, like most agencies do, it can connect to the RJ port right here. And the RJ can go on the outside and connect to the internet. So just either get your box upgraded if you have another company's, or ours comes standard with this now to allow you to do that. And yeah, if your devices are inside, you know, then you can use them with GrayKey or another tool. And then, okay, now we have the post-examination scenario. So if you have used GrayKey, or let's say Cellebrite or Cellebrite Premium, and you've got an iPhone, most likely the antennas will be turned off. That's how GrayKey does it. So they can be on a desk in a charging condition. If you have an Android, it's going to need to be shielded because you do need the passcode to turn off the antennas. So it should either be in a charge and shield bag or in a tent or in a box or something like that. Okay, back to our infographic. All right, I do want to mention tents. So if you have a tent, some agencies have tents and they've got, you know, a lot of devices inside. I'm not a huge fan of tents. I've built them before. The problem that I seem to run into with it is you have this $30,000 product, let's say. They're not cheap, and you've got maybe 50 phones inside waiting to be examined, maybe 50 that have and they're charging or whatever. You've got kind of your eggs all in one basket. If you're like me and you're a little bit clumsy, let's say you happen to trip and put a hole in your tent, all of a sudden your devices are connected on the network. So you definitely do want to have that redundancy. If you've got them inside of a tent, put them inside of some other Faraday bags. Create that separation and that redundancy. All right. Next slide. Great, that's it. So if you guys have any questions, we hope this was helpful. Please let us know. We'd love to understand how this fits into your process, what you might want to accomplish that you're not seeing here. Just let us know. Share it in the chat, please. Amanda and I are going to be manning the Q&A session after this, and we'd love to hear from you. And we do have a giveaway. All right, so we're going to give away this duffel bag. This has a separate front pocket here, MOLLE pouch. This is shielded. This main compartment is shielded. These are normally $250. We're going to put a hat inside of it and a $50 Amazon gift card. So we're sweetening the deal. We're going to ask a question, and whoever can answer the most accurately, we're going to just look at the top 3 answers and pick it. Please don't be mad at us if you think your question or your answer is better. The question is, in what frequency ranges are our Faraday bags mostly designed to block? So in what frequency ranges are our Faraday bags mostly designed to block? So thank you for tuning in. We really appreciate it. We hope you learned something, and we'll get on the Q&A now and see who's answered. All right, they're coming in quick, so gotta see who answered first here. All right, Matthew said 80 gigahertz. Matthew, that is not, that's more the 5G stuff that we talked about. Allison said 100 megahertz to 5 gigahertz. That looks to me to be the first answer that is correct. So Allison, congratulations. I think we've got you as the winner there. So we'll have to take your information later, and thank you. All right, Kent, are we're gonna open up just question and answer? I think we'll just answer the chat, right?
Yeah, so thank you, Ryan. Excellent presentation. And yeah, let's just go through some of the questions that have been put forth. And Amanda may have acknowledged some of these, but we have a question from Simon that says, how common are seal fails?
Okay, so I'm assuming that means seals in the boxes. I'm not sure if you mean the bags or the boxes, but if you look at this, for example, these seals are removable. So let me grab it. This can come out. So we include an extra set of these, and we also include an extra set of gloves, and they're pretty removable because it's fairly common. You don't want to keep the lid of your box closed all the time because it compresses those seals. They're basically just a shielding fabric over foam. If you look closely, you can see there's foam in the middle. So just like any material, they can get compressed, they can fail, and you really need these to stay good for your box to function correctly. Hopefully that answered it. For Faraday bags, it can happen. It's just a little less common. If you have a lot of wear and tear on the bag, it can happen. If you're using it for years or something like that, the fabric can wear out. So, all right. Do we have any more?
We have this question from Tom. How many phones per charge bag? I'm guessing that's how many you would put in there, or how many cables inside the bag.
Mm-hmm. Okay, so this is actually a tablet-sized charge and shield bag. By the way, it's a little bit large. The phone size is a little bit smaller, but it's going to be 1-to-1. The reason why you have that is because basically USB charging parameters. If you were to put a charging block inside of here and do 2 phones, if you were to put a USB splitter inside of here, you could do that, but it's just really not advisable. You don't know how the power will interact with the phone. If you've ever connected 5 USB devices to one source, you'll notice that it acts pretty weird. It can just kind of go in and out. So it's pretty much 1-to-1 on these. That's the best, safest way to do it. And
one tablet inside one phone, inside one bag. Got it.
One phone inside of a bag. This, I don't know if it was clear, but for this product, this is what's included. 3 cell phone tips. This is just an extender that goes in the inner USB block, so you can change out those tips. And it's just like a micro USB, a Lightning, and a USB-C. And then that's the A to A cable that goes on the outside. So you can connect that to charging block or whatever power source, the battery. So.
Cool. From Steven, do you have a UK reseller?
We do. We can connect you with them. Our UK reseller is Avatou.
Cool. I don't know if you're able to, but can you show some of the functionality of the evidence cabinet?
Sure. Yeah, absolutely. So the evidence cabinet is, I can move this a little closer maybe. Okay. So again, the process is really important to what it's supposed to do. So we don't have the bags in here right now because I was showing it putting one in. But normally it comes with 7 of those charge and shield bags of the phone size. There's going to be one in every single compartment. This is the USB charger that extends out from it, and there's a charging block in there. You can't remove this. This always stays in here. So someone comes in, middle of the night. If they're untrained, these are instructions that are going to show them what to do. We've tried to take out all of the kind of question of how to handle this. They would put a phone inside of the bag, because let's say it's unshielded, or they have another bag and you don't have this box there. Put the phone inside of the bag. This is going to stay connected. So they just kind of pull the bag out. It's like this. And I won't take too long on this because I know there's probably other questions, but sure. So it would be like this. You pull this out of there. You'd see an open compartment. Find the right tip. Put the phone inside of it. Close it, phone or tablet, because this is tablet size. Throw it back in here. Close the compartment. Pull the key out. Drop the key in here. And you're done. As far as the intake officer who's bringing in the evidence, they're done. This is charging, it's shielded, and it's locked all at once inside of there. The key's in here. So the examiner, he just checks every once in a while. He sees that there's no key inside of here, uses his admin key, opens this, opens the compartment, and then he can take this bag out because it can disconnect, bring it back to the lab, and then transfer it inside of a box to work on the evidence or just keep it charged. And some agencies that we support have purchased like 100 of the charge and shield bags, and they give them out to their evidence handling personnel, and they come in and swap it out. So they bring in their bag, connect it, take a bag out from the locker, and bring that back out into the field.
All right. From Jesse, are there any recommendations for spectrum analyzers that can be used to determine what frequencies are in a given area?
That's a good question. Yeah, to do like frequency sweeps. A cheaper one, like a good, without spending $5,000 or $10,000 and getting really technical. There was one that had at one point, Signal Hound, I think it was called. We can do some research and send this later if you'd like, but I think the one that we were using was called the Signal Hound, and it was sort of the best price to features, functionality. I think it was like $1,000, but then you have to buy antennas and such. So if you really want to get into that, you need to understand how the software works, which is sort of a technical challenge, and then buy the equipment plus antennas, and it kind of gets a little bit into that zone. So that's what I would say. That was about a year or two ago or more, so there may be one that's better now, but we can look into that if you'd like.
I see. Jeff, this is from Jeff. Do your bags interfere with RFID?
Do the bags interfere with RFID? So yes, they do. So, well, okay. RFID is like a term used, I guess, to refer to shielding products like wallets and things like that. I'm sorry. Yeah, I'm thinking in my head. Yeah, it's a good question. Okay, RFID. Yes, they will block certain ones. For example, we had a customer, I think it was forget what it was, a warehouse that was using Zebra, the company Zebra, like RFID tags. And they had a pile of those tags, and every time they had their reader and they were trying to use it on what they wanted to, it was actually reading the pile of tags. So they implemented putting all the tags in our duffel bag. It's actually what they bought, and it did block all of those tags against their reader. So the answer is yes, but it also depends. If you have low frequency RFID tags, which some are, it may not, in the kilohertz or something like that. One interesting thing to kind of note is the frequency thing is just, there's a lot of variables. If you have two-way radios, for example, and you put one two-way radio inside of our bag and you have one right outside, two-way radios generally operate in sort of lower frequencies, and they're pretty high powered because they're designed to, communicate at the longest distance possible. So a lot of times it actually will go through our bag at point blank range, and then you walk about 10 feet away and it blocks it. We're not really, our products aren't really designed to block two-way radios, so that's just something that can happen. But it's because it's high powered. RFID tags are low powered or not powered on the receiver side. so they can be easy to block even if they are low frequency. There's just a lot of variables involved, but hope that answers it.
Okay. A bunch of people want this question from Matthew. Any more information on the Android setting in airplane mode that still allows connection? Can you elaborate about that?
Give me once. I was just setting up a tablet and I saw that. I didn't even know that. I'll be right back. Give me 20 seconds.
Sure.
No, actually, I don't think I can get back to that setting. So I was just setting up this, like, I think it's a tab something Samsung, and I noticed that. I hadn't seen it before because I'm an Apple user. But it basically asked me, do you want the device to connect? I think it was for diagnostic data, but also for geolocation for some reason, even in airplane mode. So I'll research that and see if, Amanda, can you make a note of that? Because I'd love to find the actual screen that shows that. Maybe I can wipe the device or reset it and find that again. So.
Okay. Then we have from Alberto, why don't new bags already have a transparent window to see the status of the phone?
New bags. So if you mean all bags, the answer is cost. So this material, the transparent material, which I'll demo really quick so you can see, is just more expensive. It's to get that transparency requires more in the way of material costs is all it is. So if you want that and you want to see the device, it's kind of hard to see here because we have heavy lights, but well, no, you can see it pretty well. So that window lets you confirm signal cutoff, lets you see if the device is charging. But just by way of example, this $23 bag that I was showing, the Velcro one, if you want the window version of that, I think it's $48 or $50, something like that. So it's almost double the cost. So for forensics, we get a lot of investigators who do get our window bags if budget permits.
Okay. Are there any options for disposable one-time use Faraday bags?
We don't. Yeah, the problem is to get a really good Faraday. Okay. So to get a really good Faraday enclosure, like this bag, for example, there's 2 layers of the shielding material on both sides. This material is not cheap. It's metallic fabric. It's customized for these frequencies, and we build this bag in a certain way that it's going to block well. What you have with a lot of the products out there, there's some that claim to block all signals to do it really well, and they're $5 or 50 cents or whatever disposable. They're just not going to work as well. If you get them and you try them yourself, get near that high-powered Wi-Fi transmitter, you'll find that they just don't work. So we don't offer that. We don't recommend it either. I know sometimes budget constraints, people are asking for that, or these end up in the evidence department or evidence lockers. Yeah, but we don't recommend the one-time use ones.
Mm-hmm. Do your bag, oh wait, I'm sorry. Isn't 5G predominantly 6 gigahertz? Someone just wants to clarify.
Yeah, so 5G actually implemented out in certain areas. From our research and what we're hearing, seems to have different carriers, seems to have different characteristics. So it may be 6 gigahertz in certain areas. Just to expound on kind of what we've been hearing and what I said before. So originally it was intended to be largely high gigahertz, 40 to 80 up and beyond that. Because of those challenges with hitting structures and the information getting fractured and needing to be more line of sight, okay, that means you need a lot more towers. That's a lot more expense. I think the actual practical implementation and installation of those has led a number of the carriers to then use other frequencies that they've already had and just beef up the tech using towers that they've got, bring them to current, add in higher powered transmitters for those. So it's kind of, I think, like a combination of lower frequencies that have already been used plus the higher. Depends on which area they're implementing it in, how many towers they've got, and so on. So yes, 6 gigahertz is likely to be used in a number of areas.
Shafiq asks, can you block Bluetooth connections? He is concerned with devices in airplane mode and iOS devices beacon location through Bluetooth via other iOS devices in range.
Definitely. Yeah, so Bluetooth frequencies are the megahertz. Well, it depends, but I think it's 800 megahertz. Yeah, I just lost that which frequencies it's at. But yes, the answer is we do block Bluetooth. We block it really well. Bluetooth is not that hard to block because it's lower power, just the spec on it, the frequency plus the power that it's usually implemented in means that it's pretty easy to block. So we do block Bluetooth. And yes, you should be concerned with that because devices can connect with other devices. You don't know what's happening. It's just another antenna that you want to make sure isn't operating on the suspect device.
Okay. Have you seen any challenges to the chain of custody?
Well, I'm not quite sure exactly where that question's geared because there are a lot of challenges in chain of custody. I guess maybe with the implementation of this process and what we have, what we kind of laid out here. Not yet, not really. I don't actually think we've had anyone say that they were examined on or cross-examined on this process and had any issues. Usually that's not an area that we get too involved in. You know, sometimes we'll be answering questions if it does end up in court and the examiner has to answer questions, but it's pretty seldom. So because it's seldom and we haven't had it recently, I guess my general answer would be no. We haven't run into any issues with that.
Okay. From Brian, any problems blocking AirDrop since it uses Bluetooth plus Wi-Fi?
No problems. Again, our products are going to be designed to block all frequencies that the phone is using. So it's pretty mind-boggling. I mean, if you look up what an iPhone is now, it has like, you know, I don't know, 10, 20 bands. It can operate in every country. If you look up a chart of the different frequencies in every country, it's incredible. I mean, it's like, you know, basically there's a lot of tech in this. But the range of the antennas that are in here and the bands that they go, it's pretty much, you know, it's a question that we asked to get the giveaway, low megahertz to 5 gigahertz, and Wi-Fi, Bluetooth are operating within that range. So no, we don't have any problems blocking that. And we build our bags to be, we say kind of 70 decibels of shielding, just as a general, you know, average, as a general description of how well they block. We build them to block way better than we need to for essentially any real world scenario across that spectrum. And that's, you know, multiple layers of fabric, construction methods, things like that. So no, we don't have any problem with that.
Who would you recommend to test field Faraday bags?
Well, who would we recommend to test field Faraday bags?
That's what the question is.
I'm not quite understanding. Maybe if there's a consultant service or something that I'm not exactly sure what that question would mean.
Mm-hmm.
Maybe we can get some clarification on that while we answer another one.
Yeah, so if you want to clarify, do so in the chat. And then from Jesse, are you aware of any process that will allow an LE agency to legally obtain and operate a signal jammer in the United States?
I'm not. They're illegal. They're illegal here, and they're really illegal in Europe. Doesn't mean they're not used. I think the federal agencies, when they want to, they'll use them for certain things. I can't say that officially. It's just, you know, I think it happens, just like other equipment. But as far as law enforcement agencies to legally do that, no, I don't think so. I think it's kind of generally a no-no.
And then I'm just trying to get this last question. And I think the last question might have been not who, but how frequently do you recommend to test field Faraday bags?
Yeah, I mean, if you have 200 patrol officers and they all have Faraday bags and they're just cheaper Faraday bags, I think your answer is probably you're not going to test them. You're probably just going to tell them, hey, if one looks like it's got a rip in it, or you destroyed it yourself, bring it back and we'll replace it. If it's the more expensive products that we have that are going to be for your evidence handlers, I would say to test them, once every 6 months or something. Usually, unfortunately, the way that someone finds out there's an issue, and we get this very rarely, it doesn't happen often, but it's going to be a phone that they see is connecting to the network. So obviously you don't want that on a suspect device, but if you have Faraday bags and you have the ability to implement a process, I'd say, try to have them tested every 6 months, bring them in and just do the simple kind of Wi-Fi test on them, at least if you don't have a signal analyzer. One thing I want to mention with distributing out Faraday bags, RF shielding to your field personnel, we have a serial number on every one of the bags. You can see it here. So this really helps with asset tracking. You can figure out who's got what bags, and it can help you with the chain of custody and figuring out where they go. Every bag has a unique one. If you've got a repeat offender of losing their bags, you can figure out who that is and reprimand them accordingly. So, yeah.
Okay. Someone asked where the bags are made.
About 80% of our products are made half an hour away from here. So we're in Santa Barbara, California. Most of our products are made in the US here. We do have some that are really hard to make here. There's just not production facilities. Those are mostly our like waterproof bags. Like this, for example, this is a dry shield tablet bag. So it's got that magnetic connection there, but this is a waterproof material. And then you've got the shielded materials inside here. So this is made primarily in China. We do have it like lined here, but yeah, that's an example of one that we don't make here because it's just difficult and expensive, or actually near impossible. So.
Why do iPhones not need to be shielded?
Okay, so don't take my word as the final word on this, right? Because I don't want any issues with your evidence. But as far as we understand, and speaking with GrayKey actually face to face recently, GrayKey passcode and you're waiting for the screen, iPhones will have the antennas turned off by GrayKey. We do talk to agencies, and we do have agencies who don't trust that, which is probably good. And obviously, because these are the products we have, we want you to use more of them. But generally, that redundancy is a good idea. So if you do have an iPhone, you can keep it in a shielded enclosure, but we know people who aren't because it turns off the antennas. We have sort of, I guess, been instructed that Android phones, you can't do that until you get the passcode. So they need to be shielded.
Okay. Have you seen any defense counsel arrange for an expert to challenge the reliability of the bags?
No, because we just don't usually get involved in that side. As the equipment provider, some tool providers like Cellebrite, Magnet, GrayKey, they need staff in place to support defense examination. These products are usually a little bit more simple to explain. I don't think they get scrutinized in that way necessarily. And if they do, I think it's usually pretty feasible for the examiner to provide the information that's required to shut down that line of questioning. So no, we don't really get contacted to provide a whole lot of information there or see any issues with it.
Gotcha. And then just when you're testing a bag, is it mostly just a visual inspection, or is there anything else you can do?
Okay, so there's links in the presentation to this, but a really great tool, again, we're biased because it's our tool, but it has been really great, is this app called Faraday Test. So you can download this on iOS, called Faraday Test. On Android, it's called Faraday Bag Tester. What it does is you place it inside of the bag and it gives you a really nice visual of your signal. We used to be able to grab this in decibels because we were able to grab something from Apple as sort of a hidden API. Apple shut that down, so we had to basically just do an on-off kind of signal indication. But this is showing my Wi-Fi signal is activated. If I were to turn off my Wi-Fi, which I'll do right now, I'll stop it. Okay, let me just stop it. It shows nothing was blocked, right? I'll just do this test right now. Why not? It's pretty quick. Okay. Oop, got a lot of bags here. Okay, this shows nothing's blocked. It had signal the whole time. If I click stop and start again, you can see that the signal is going there, Wi-Fi. Drop it into the bag. It's still going because I haven't closed the top. Close the top of the bag. I'm trying to keep it from touching it because it can activate the screen. Okay, you see how there's that bottom blue line is still going, but there's no bar there.
Yeah.
Still running the test, but it's blocked. And then when I pull it back out, and our Wi-Fi is actually right over here in that closet, which you can see right there. So it's pretty close. Now that I pulled it out, it's going again. So then you click stop. And it's going to show, great, green check marks, it was blocked. And then if you turn off your Wi-Fi antenna, it's going to activate the cell signals. For Android, because it's not as sandboxed as Apple, we can access those antennas at the same time. But this is a really good way, just a quick visual. Get really close to as high powered a Wi-Fi as you can, turn it on 5G, and do a 2.4 gigahertz test and a 5 gigahertz test using this. If it's going to block Wi-Fi, the chances are about 100% that it's going to block cell signals. So usually you only need to do a Wi-Fi test.
Okay. From Jerry, how can you tell the presence of an active eSIM in an iPhone or an eSIM?
How can you tell the active presence of an eSIM? Okay, good question. I don't know the answer to that. Yeah, I don't know the answer to that. If you've got a SIM in the device, I don't know if there's a key code that you can press. I'm sure there probably is. But I'd throw that to another examiner, actually, if someone wants to answer that. That's what you do. And my wife's a teacher. That's what you do in a classroom when you don't know the answer to a question. You throw it to the rest of the class to answer it. So we'll go ahead and do that. That may be a simple one. I don't know. Not exactly sure. But we'll see if anyone comes up with it.
Cool. So I believe that is all of our questions. Someone asked if they can find this video or recording. I will be sending out a recording as well as a link to the PowerPoint in an email this afternoon or tomorrow morning. So keep an eye out open for that. And I just want to check out, see if there's any last minute questions. Just give 5 seconds.
Yeah, good questions. Thank you for asking those. That's great. If anyone else has anything, let's see. I don't. Let me go up in the chat here. Okay. Also, I did want to tell you all, if you want to purchase our products, go to Teal. Teal's awesome. They have immense knowledge on these products. They can recommend. Honestly, I mean, we want everyone using shielding regardless. They provide multiple shielding products. So, you know, if they think that one of our products is not the best, they'll tell you that. So definitely go to Teal, and you know, they'll provide you with what you need. So, any more questions coming through? Oh, we got a thank you from Matthew. Great. Yeah. Thank you, Matthew. Thank you for the thank you. Yeah. How can you tell the presence? Okay. I think that's all we have. So.
Did you answer this one? Are your questions compatible with blockchain of evidence on RFID tags?
Wait, are your questions or are your
systems?
And are your systems I'm not saying.
Let me repeat it. Okay. Are your systems compatible with blockchain of evidence RFID tags?
Okay. I don't know. Blockchain of evidence RFID tags. I don't know what frequency they operate in. Amanda, do you wanna just pop that into Google really quick? Blockchain of evidence RFID tags. See if you can find the frequencies that they might typically operate at. I think we'd have to look at a spec on them. You know, that's usually what we have to look at and check. Generally, RFID is operating in a frequency that we're covering that we'll block. But I don't know if we can find anything on that, so we'll see.
Okay, great. So thank you very much. I think this concludes the presentation. Thank you everyone for attending. And congrats, Allison, on being the winner. And you'll receive an email from me with a recording as well as the PowerPoint slides. And thank you, everyone. You can tune in next week as well. We have Maggie Gaffney presenting on SQLite. So you'll be able to see more information as well as a registration link for that as well in the email I will send you. And that's about it. Thank you, Ryan. Thank you, Amanda. All right, everyone, have a great afternoon. Stay safe, stay healthy. Thank you very much.
Thank you. All right.
And I just want to say to everybody, if you have a private question, we'll work to get back to you right away.
Yep. All right. Thank you.
All right.
Thanks.
Bye.